Hi, I'm Wu, and I'm gonna record a video for question number 2 in homework 6 for the course probability and stochastic processes. So in this question, the fxy equals to b, and x squared plus y squared is less than or equals to 1, and this function equals to 0 otherwise. So the question number A asks us to find b so that the above defined function is a valid joint function. So as we know here, we take the integral of this function, and if this function equals to 1, so that the this function is a valid joint density function. So since this function equals to b, so we can put the b outside of the integral, and so that we can get b times integral from -1 to 1 times the integral from negative square root of 1 minus x squared to square root of 1 minus s squared times 1 dy dx equals to this will be equals to 1. So after calculation, we can get b times integral from -1 to 1 times 2 times square root of 1 minus x squared dx. And in this step, we set x equals to sine t, so that we can get from this equation, we can get b is this equation is equals to b times integral from negative pi divided by 2 to pi divided by 2 times 2 times cosine t squared times dt. And we calculate this part is equals to pi, so b times pi, if b times pi equals to 1, this function will be valid joint density function. So in the situation that b equals to 1 divided by pi, this function will be that valid joint density function. So, and question number B, it will require us to find the ex and ex on the condition of little y, and ex on the condition of big Y, and ey and ey on the condition of little x, and y on the condition of big X and ex times y. So we can easily tell that ex is equals to 0, since the ex following the equation like this, from negative to infinity, and from negative infinity to infinity times x times fxy xy dx dy, which is equals to 1 divided by pi times integral from -1 to 1 times x times the integral from negative square root of 1 minus x squared to the square root of 1 minus x squared times 1 dy dx. And this equation here is equals to 2 divided by pi times the integral from -1 to 1 times ix times square root of 1 minus x squared. So this part is an odd function. So after taking the integral of this function right here, so this whole part will be 0. So since we can use the same function to easily tell that ex under the condition of little y, and ex under the condition of big Y is all equals to 0. I can prove here. So ex under the condition of little y is equals to the integral from -1 minus y squared to the square root of 1 minus y squared times x times x divided by pi times dx. And the whole thing is divided by integral from -1 minus square root of 1 minus y minus y squared to square root of y minus y squared times 1 divided by pi dx. So and also since the x is odd function, so the above part will be 0, so the whole equation will be 0. So in the same way we can get this part, this ex under the condition of big Y is also equals to 0. And since the symmetry, we can from since ex and also because of ex is equals to 0, so we can easily tell that ey is also equals to 0, and ex on the condition of big Y is equals to 0. So this is also equals to 0, and since this is equals to 0, so this is also equals to 0. So and last, finally, we also need to find exy. So to calculate it, maybe a little bit complex, we can use this. So the ex times y is equals to e of xy on the condition of x. So this is also equals to e of x times e of y on the condition of x. So in a previous part, we have already found out that this part is equals to 0. So this will be e of 0. So the whole equation will be equals to 0. So and we finished question number B. So the number C asks us to prove or disprove xy are uncorrelated. So this is very simple. Since exy is equals to 0, so that it also equals to ex times ey, since both since ex is equals to 0. So xy. So from this equation, we can tell that xy are uncorrelated. So thanks for watching.